నిజమైన విద్యకు నిలువెత్తి బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. నిజమైన విద్యకు నిలువెత్తు సాక్ష్యం. 20 ఎకరాల సువిశాల ప్రాంగణంలో కళాత్మక నిర్మాణాలతో స్వచ్ఛమైన ప్రకృతి ఒడిలో ఆత్మీయతను ఆస్వాదిస్తూ విద్యా సౌరభాలు వెదజల్లుతోన్న చదువుల నిలయం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. క్రమశిక్షణకు మారుపేరుగా సంస్కారం, నిబద్ధత కలిగిన బోధనతో పాటు మానసిక, భౌతిక వికాసం కోసం సువిశాల ఆట స్థలంలో వ్యాయామం, యోగా, వాలీబాల్, త్రోబాల్, క్రికెట్ మరియు ఖోఖో లాంటి ఆటలు రోజువారీ టైం టేబుల్లో భాగం చేయడం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజీకి మాత్రమే సాధ్యం. బాలబాలికలకు ప్రత్యేక హాస్టల్ వసతితో రుచికరమైన పౌష్టికాహారం, 24 గంటలు అందుబాటులో ఉండే సీనియర్ లెక్చరర్స్, విద్యార్థుల మెదడుకు పదును పెట్టే ఫిజిక్స్ ల్యాబ్, కెమిస్ట్రీ ల్యాబ్, బొటనీ ల్యాబ్ మరియు జువాలజీ ల్యాబులు, నీట్, జేఈఈ మెయిన్స్ మరియు జేఈఈ అడ్వాన్స్డ్ పోటీ పరీక్షలకు సన్నద్ధపరిచే విద్యా ప్రణాళికలతో బీరం
Good evening, everyone. So, all of you able to hear my voice? Is audio clear? Let me know. All of you able to hear me? Vishnu, Sanjay, Akhil, Yashwant, Hemant. Good evening. Good evening. So today is physics subject. Akhil. Or Akhil. Okay, Pablo, very good. Somebody is asking which subject. So today is physics class. So you might have chemistry tomorrow. Okay. So we try to go for alternate days. So that you will also don't get bored. Huh? Good evening, Charat. Good evening, Ignesh. Good evening, everyone. So all of you open the notebooks and see what we were doing yesterday. If anybody joined newly today, how many of you joined new today? How many of you joined new today? Raise your hand. How many of you joined newly today? Raise your hand. Nobody joined, huh? Everybody joined yesterday, right? Okay, very good, nice. So what we were discussing? What is the concept we were discussing? We were discussing the prism concept. Am I right? Very good. Now, as it is a prism, what are the main? See, whenever some topic is there, you have to know that what things you need to remember. Okay, some parts you need to remember. Okay, so that you can solve the questions quickly. Because for every question we don't derive, right? So that's not a good sign. That's not a good method also. So first we learn the things by deriving, but once derivations and learning is completed, then we have to remember or connect with the key points. Okay, now this is the methodology to solve the questions quickly. What are the methodologies? You need to connect with some important ideas, important points, so that those will be useful in solving the questions. Okay, got it? So just I'll go with a recap. Whatever what the yesterday we have done, we will see that what important things you need to remember. Okay. Now this is the prism. Okay, now then prism angle is A. This is the angle of prism. I told one more name for this also, which is also called as refracting angle. Refracting angle of prism. Sometimes to confuse you, they will give you refracting angle of prism. Refracting angle of prism or angle of prism. Anything is same. Both will have the same meaning. Okay. Yeah. Suppose that a ray is incident on one surface, one refracting surface, at what angle? This is the normal, let us say. This is the normal I1 and I2. And what is the angle of incidence is I1? Then it will refract, will bend towards the normal R1. Again, it will fall at an angle of R2 and comes out at an angle I2. Okay, then this I2 is called as angle of emergence. I1 is called as angle of incidence. These are the angles inside the prism. R1, R2 are the angles inside the prism. Okay, understood? Very good, Dipti, correct. So, what is the important thing you need to remember? What is the relation between R1, R2 and A? A should be equal to R1 plus R2. This is the one idea you need to remember. Dipti, very good. Can you tell me any other ideas? What are the other relations we have done yesterday? Deviation angle. Okay, very good. What is the deviation angle value? All of you can remember the deviation angle or not? Okay, derivations are always important for what? Your board exam. Like 10th class exam, 10th standard exam, 12th standard exam. For those exams, derivations are important. But understanding the derivations at the same time, remembering some key points is important for competitive examinations. If you get that logic, it is very easy for solving the questions of the competitive exam. Okay? Yes. What is the angle of deviation? Angle of deviation is we write down as delta. What is the angle of deviation here? To extend the incident light, this is the incident light extended. If I extend the you can say refracted light or final emergent light or refracting light, then this angle is called as what? Delta. This is the initial path. This is the final path from the prism. The angle between initial and final path of the prism is called as angle of deviation. Okay, Sai, very good. Sanjay, correct. Okay, Dipti, very good. Very good response. People are answering. That's a good thing. Then what is the deviation we can write down? I1 plus I2 minus A. Okay, na? So these are the two important things we need to remember. These are the general expressions. Okay, now for any deviation, for any angle of incidence, you can apply these principles. There is one more thing that is called as what? For minimum deviation. For minimum deviation, what is the condition? When deviation will be minimum. When deviation will be minimum. Anyone you can respond in the chat. When deviation will be minimum. I want to know that what is the minimum deviation value. I1 is equal to I2. Very good, Vishnu. Very good, Hemant. Okay, for minimum deviation, what is the condition? I1 is equal to I2. That implies R1 is equal to R2 also. I1 is equal to I2. That means R1 is also equal to R2. Why? Because we have one more thing, that is mu is equal to sin I1 by sin R1 here. For the first fraction, sin I1 by sin R1 is equal to mu, which is also equal to sin I2 by sin R2. Sin I2 by sin R2. Very good, English. That point I am going to explain. You only told. Very good, nice. Refractor ray will be parallel to base. Okay, if I1 is equal to I2, then both will cancel. Then R1 is equal to R2. R1 is equal to R2. So I1 is equal to I2. So that I am taking it right. R1, R2 values I am taking it R. Then we got the mean. What is the refractive index of prism? What is the refractive index of material of prism? Prism material has some refractive index, right? Yes, R is equal to A by A. Then we have sin minimum deviation plus A by 2 by sin A by 2. Okay, that is the refractive index of the prism. Okay, these are the some ideas we discussed yesterday, right? So let us learn a little beyond this. Okay, let us solve some questions also related to prism. Okay, so hope you remember all these things. Even I told graph also, but if you remember the graph, that's very good. Otherwise, not that much important. You need to understand these parts. Okay. Yeah. As Ignesh said, for minimum deviation, I'm talking about minimum deviation. Okay, now this is the triangle prism, equilateral triangle prism. This is A. Okay, now, for minimum deviation, what happens? We know that I1 is equal to I2. Already I wrote conditions. I1 is equal to I2. R1 is equal to R2. Am I right or not? Those are the minimum deviation conditions. R1 is equal to R2. See both the angles here normals. This is R1. This is R2. These two are equal. These two, R1 is equal to R2. That means how the ray should be? Ray should be parallel to base. This base and this ray both should be parallel to each other. Why? Because if R1 is equal to R2, then these angles also will be same. 90 minus R1, 90 minus R1. Okay? 90 minus R1, 90 minus R1. These two angles are also same. Whenever these two angles are same, then this angle is 60, then this will be 60 and 60. I'm talking about equilateral triangle or equilateral prism. If prism is equilateral prism, what is the angle of prism is 60 degrees. This is 60. Then these two angles are same. That means this will be 60 and 60. This also 60 and 60. Then this ray will be parallel to base. Ray will be parallel to base also. Got it clear? Okay, na? So that means this is the incident ray and this is the emergent ray. Even both will have I and I. Okay, na? Angle of incidence and angle of emergency. Even angle of R1 R2 also same, which is equal to R. Simply I am writing as R1. And for minimum deviation, what I can write down? The ray inside the prism. Write down and remember, very important idea. Okay? Ray inside the prism will be parallel to base of prism. Okay, now ray inside the prism will be parallel to what? Base of prism. Clear? No, Dipti, not like that. It's not minimum deviation. Rainbow concept is different from minimum deviation. The rainbow is dispersion of light. Okay, Dipti. Okay, this is the one point, and the next point is next important idea, or I'm giving a question. Okay. The question is, I'm taking the one prism with angle, let us say 60 degree. Okay, now angle of prism is how much? 60 degree. Now, what is the refractive index of the prism is? Refractive index of the prism I'm taking as something like a root 2. Refractive index of prism I'm taking as root 2. Then, okay. If ray is incident at what angle? Let us say that 60 degree. Ray is incident at an angle of 60 degree. I think you will get more calculations. Wait a minute. We'll change it. Okay. Because some people don't know sine inverse, cos inverse. No. So mathematical some problem is there. That's why I'm going with another question. If refractive index of prism is mu, refractive index of prism is mu, then for what angle of incidence? What angle of incidence? Let us say I1. Ray will come out along the boundary. Understood? Emergent ray has to come out along the boundary. This is called as what? Grazing emergence. Grazing emergence. Understood? So I'm writing the question. Very good, okay, correct. That is the idea. Try to understand. Try to solve it. Okay, now for what angle of question I'm writing? Stevens. For what angle of incidence? For what angle of incidence ray comes out of prism along its surface. That only we are writing as what? That only we wrote as grazing emergence. Okay. All of you try this. Let us see how many of you will get. Little big expression you get. Don't worry about it. Try to keep as it is. Don't simplify. Okay, 45. No, Sharon, no, maximum angle. Although, okay, sine inverse mu. No, you will get a little big expression. Although, try for a value, not like maximum and minimum. Try for the value. You will find some I value, something like sine inverse or something. Or somebody posted. Sharon, you don't get exact angle 45. Sharon says. Okay. Try for this. For grazing emergence, what are the conditions? Angle of obvious angle of prism is here. That also will be there. In the answer, you will find angle of prism, even refractive index of prism also. Anyone got the answer? Almost 90. No, not part. Danish, no, not 90. This is 90. Angle of refraction is 90. You can say angle of emergency is 90. Now solve in reverse, you will get it. Solve in reverse. Okay, try to solve in reverse. Bsrjc, you don't get values. You don't get values. You will get some expression. Bsrjc, you will get some expressions. Okay, not values. First, solve the here. See, what are the inside angles? We can take R1, R2. Inside the prism, we can take R1, R2. Very good. Somewhat like that. Sine inverse, sine R1, not R2. Let us see. Okay, now we go for refraction at second surface. If I go for refraction second surface, mu into sine R2 is equal 1 into sine 90 see once. All of you understood? I am applying this Snell's law. At second refraction. Snell's law I am applying at second refraction. Okay, what is Snell's law at second refraction is? Mu into sine R2 is equal to 1 into sine 90. All of you understood? Refractive index into sine of angle in that medium is constant. Refractive index is mu. What is the angle in that medium is R2. And what is the refractive index of A? 1. And what is the angle of refraction here? 90. Right? So 1 into 90 and mu into sine R. Clear? Okay, now 1 into sine 90 is equal to mu into sine R. Then I can find out the R2 value. So mu into sine R2 is equal to how much I can write? 1. Because sine 90 also 1. Sine 90 is 1. 1 into 1, 1 only. Okay. Then what is the sine R2 value is equal to 1 by mu. What is the R2 value I can write down? Sine inverse 1 by mu. Take the sine on this side. We will get inverse functions. Okay, now sine inverse 1 by mu will get. This is R2 value. But what we require the I1 value. How to find out the I1 value? Once you know R2 value, you can find out R1 value. How? R1 plus R2 is equal to A. Then what the R1 is equal to? A minus R2. Then A minus R2 value. Sine inverse 1 by mu. Okay, now? R1 is equal to A minus R2 I wrote. A minus sine inverse 1 by mu is the R1 value. But we want to find out I1 value. Then how I1 and R1 are related? I1 R1 related again by using the Snell's law. 1 into sine I1 is equal to mu into sine R1. Okay, are you getting? Again, I apply this Snell's law for the first refraction. 1 into sine I1 is equal to mu into sine R1. Then sine I1 is equal to mu into sine R1 value. What the R1 value is? A minus sine inverse 1 by mu. Okay. Then I want to find out I1 value. Then take the sine on the side. Then I1 is equal to sine inverse. Don't deflect. Okay, now you have to write down as it is. Mu into mu sine of A minus sine inverse 1 by mu. This is the I1 value. Okay. So this is the question as given in JEE main. JEE means after your 12th standard they are doing this question. Okay, same as it is, no change, nothing at all. But still you can solve with your 10th class standard thinking. Okay, but application is little beyond. For that you need to practice. You have to go through the different type of questions. Then you can solve the questions of JEE, no doubt. Okay, with a proper guidance, with a what is it? Good data. Data means information. for a particular chapter, you need to know each and every. Okay, na? There will be no shortcuts. Shortcuts won't be there. We have to solve. Maybe I'm solving step by step. I'm taking a more number of steps because you need to understand. Everybody has to understand. No, that's why I'm writing each and every step. But otherwise, no need to write down these many steps. You can directly write down everything. It will be solving 2-3 steps. Also. Don't see the steps. Try to understand the phenomenon. You have to apply this Snell's law at both the surfaces. Okay? Then solve the one angle. Snell's law for these two. Then you will get R2 value. R1 plus R2 is equal to A we know. Then R1 value will get. Then automatically I1 value will get by using the Snell's law. That's it. Okay, don't afraid of this expression. You need to habituate to little big expression sometimes. No need to solve. Directly you have to write down the inverse terms. Take the sign on the side to the side, then it will be sign inverse. Okay, now then R1 plus R2, R1 as it is I go. A minus sin inverse 1 by B. Then again 1 into sin A1 is equal to B into sin R1. Then write down the R1 value. Then I will write down the calculate. Exactly. For refractions, Snell's law is the basic principle. Okay? Any other doubt? Once go through it. See step by step. If you have any doubt, let me know. I'll discuss it. Okay? So both should be visible. That's why I'm going out of the screen. So let me know if you have any doubt, I'll explain. But solve step by step. Write down in your notebook step by step. Then you will understand all these things easily. Okay? All of you understood? Huh? Any doubt? Let me know if you have any doubt. Doubt unte cheppandi. We'll discuss. Okay, finished done? Okay. So I love this. We'll move to the next part. Huh? Okay, finished done. So this is the refraction at plane surfaces. Let us go with the refraction at curved surfaces. Because a lot of classes happened. Let us go with lenses and phenomena. Okay, refraction at curved surface. Anyone know how to apply the refraction at curved surface? It is there in your textbook, right? Can anyone tell me what to do when a refraction is happening at curved surface? Means two mediums are separated with a curved surface. Okay, I'll show you. I think we are having something. Exactly, aperture, lenses. Some people are saying, Dick is saying aperture, actually saying all lenses. Something like this. See, this is the one glass. Okay, you will see this is the curved one. You can see this is the curved, right? This is the curved one. So here medium is air. and this is the medium glass. If ray is going from air to glass, it is a refraction curved surface. Whereas this one is called as plane surface. Planar convex. Yes, you can call this one as planar convex, but not exactly. It is half of the what do you say, the disk. Okay, this is the plane surface. If ray is going from this medium to this is air, no. On this side we are having air, and this is the medium. Then ray goes from air to this glass. Then refraction happens at plane surface. This is the plane surface, and this is the curved surface. Understood? Okay, so the medium between or boundary between two mediums are separated by curved surface, something like this. Let us say this is the curved surface. This is having the refractive index mu1, and this is having the refractive index mu2. mu1 and mu2. This is completely one medium. This is completely other medium. As I told you, one side air, other one is glass. Okay, na? Air and glass you can do. Something like this. Okay. Whatever I have shown you, same thing I am doing. Suppose this is the medium, and this is the air, and this is the glass. Imagine this is completely glass is there. On the right side glass is there, on the left side air is there. Okay? Anybody got this idea? Exactly the thing, center of curvature, pole, principal focus, those things. Like after this, it will be connected to lenses concept. It will be connected to lenses. Okay? Suppose that one ray is incidented here. Suppose this is the ray moving in the air and incidenting the curved surface. Then what will happen? Here also refraction happens. Here also refraction happens. But what we require for angle of incidence or angle of refraction, we require the normal. This is called as point of incidence. Okay, na? So same way here also you have to draw the normal. What is the meaning of normal? No, Partner, it's not like that. Wait, listen to me carefully. There is angle of incidence also. Very good, Jyoti. Normal is nothing but what? What is the normal? Normal means if you extend the surface, you will get one sphere. Okay, this is called as curvature, part of a sphere. Okay, Akhil, normal is perpendicular to surface. Now, what is the perpendicular to surface here? Perpendicular to surface means now you extend this, you will get a one sphere. Okay, then this will be the some center of curvature. For this sphere, there will be some center, right? Now, this is the point of incidence, and this is the center. Center to point of incidence. If you connect, that will become the normal. No, not tangent. Psi perpendicular to tangent we call it as normal. This is called as tangent. Okay, I am drawing another diagram here. If this is the sphere, to this point, let us say P is the point, then this is the line we call it as tangent. This line we call it as tangent, and this line we call it as normal. This is normal, and this is tangent. Okay, na? Very important thing for physics. You will get so many places with these things. For spherical or curved things, point of contact. There is no point of contact. There will be a point of incidence. This point we call it as point of incidence. Okay. So then this line, point of incidence, you connect with center of curvature. The line joining the center of curvature and point of incidence, we call it as what? Normal. Then this is the incident ray. The angle between normal and incident ray, we call it as what? Angle of incidence, which is right. Now, if mu1 is the air and mu2 is glass, then ray is going from rarer to denser. Then ray goes from rarer to denser. If it is moving from air to glass. Okay, clear? It is moving from air to denser. Air to glass means rarer to denser. Clear? Rarer to denser. Then ray will bend towards the normal or away from the normal? Ray bend towards the normal or away from the normal? Very good, towards the normal. Nice. English correct towards the normal. No, Dipti, not like that. Not with focus. Not everything should be called as focus. I tell you, wait. Focus. What is the focus? I'll discuss. Very good, Hemant, Danish. Very good. Towards the normal. Towards the normal. Nice. Very good. Nice response. As the ray is going from direct to denser, they will bend towards the normal. That means it will be something like this. Then this is the angle of refraction, which is less than angle of incidence. Okay, Dipti, very good. Understood? Huh? So this is called as refraction at curved surface. Ray is refracting at curved surface. That's it. Same principle. Same of what we have studied. Only what is the difference here? The difference of previous and here is previously medium boundary is straight line. Right? So this is mu1, let us say this is mu2. Below is the mu2 medium, above is the mu1 medium. Then if a ray of light is incidented and this is the normal, we directly write down the normal perpendicular. But here normal is the line joining the point of incidence and center of curvature. So that is the point you need to take care. That is the point you need to remember. Okay? Na? What you need to remember is, if you join the line from point of incidence to center of curvature, then you will get a one line. That line we call it as what? Line we call it as normal. Okay, understood? So from that angle of incidence, angle of refraction, the story is same. If ray is going from direct to denser, it will bend towards the normal. If ray travels from denser to rarer, it will bend away from the normal. That phenomena is same. That phenomena does not change. Again, even application of Snell's law also does not change. What is the application of Snell's law? By Snell's law, what we can write down? What is the Snell's law I told? I told that Snell's law, refractive index into sine of angle in that medium is constant. Am I right? Refractive index into sine of angle in that medium is constant. Now see, what is the refractive index here? mu1. So let us go with mu1. And what is the angle in that medium? I. Then mu1 into sine I is equal to, what is the refractive index? Next medium refractive index is mu2. And what is the angle in this medium is r. Then I can write down mu2 into sine r. That's it. Same principle of Snell's law. There will be no change in Snell's law also. Snell's law also will be same. All of you understanding? This is called as refraction at curved surface. All of you understood? Any doubt? Write down. Again, we discuss in another way. We will discuss in the terms of object and image. Okay, na? No. Refracted ray is not radius part. This is the refracted ray. This is the radius. This is the radial. This is the center. Center is this point. This is the point of incidence. This is called as point of incidence. This is called as center of curvature. Okay, na? This is the point of incidence and this is called as center of curvature. Okay, understood? Huh? So, go down. Huh? I think all of you understood. Can we calculate normal means what you want to calculate? Radius. Yes, radius we can calculate. By sufficient information, we can calculate radius. Okay. If information is given, radius will be calculated, but most of the times, radius will be given in the question. In the question, they will give the radius. Vishnu, okay? Hemant, Dipti, all of you understood? Okay, very good. So let us go with object and image cases. Let us say that suppose, see, this is the medium boundary. One medium is V1, other medium is V2. Okay. Left side medium I'm taking as refractive index as V1. Right side medium refractive index is V2. Okay. Now I am keeping an object here. This is the object. So you can call it as V1 is the object medium. Then where we are expecting the image will be formed in the mu2 medium. Image will be formed in the mu2 medium, right? So I think all of you know what is the how to construct an image. How to construct an image? If I take one ray along the one line that will go undeviated, this line we call it as what? Principal axis. Do you remember this? What is the principal axis? Principal axis is the line along which ray will go undeviated. Now, if you extend this curvature, then this we call the center of curvature. As I told you, if you extend the curvature, this is the curvature as given. No? If you extend it, you will get one sphere. You will get one sphere. There will be some center of sphere. C is called the center of sphere. Exactly, sure. That one I'm saying. Now this point we call it as pole. This point we call it as what? Pole. And this is what? Center of curvature. So many books they'll give you like what? The line joining the center of curvature in pole. The line joining the center of curvature in pole we call it as what? Principal axis. But you need to remember like what is the principal axis? Principal axis is the line along which light ray will go undeviated. And they deviate over refract cargo. And the angle of incidence angle of incidence is 0. Angle of refraction also is 0. Okay, no? For normal incidence. That we can call it as principal axis. R by T is focus, no the T. R by T won't be focus. R by T is focus for what? Mirrors. We are talking about mirrors. Okay? Yeah. So I'll take one more ray. So this is the one more ray. Because from the object you will find so many rays comes out, just like tube light. Now you see the tube light or any light inside your home, then light will goes in every direction. In all direction light will go. Right? So like that I am taking the only two rays, you can take any number of rays. Now I am taking the one more ray, then this will be the normal. Okay, see, this is the point of incidence and this is the center. Joining the point of incidence and center we call it as normal. This distance we call it as what? Radius. This is R, even this is also R. PC length is R. PC is called as radius of curvature. PC is called as what? Radius of curvature. Okay. Distance between the P point and center of curvature. Okay, this is the normal. Then if mu1 is rarer medium, mu2 is denser medium, it will bend towards the normal. If mu1 is denser medium, mu2 is rarer medium, it will bend away from the normal, right? So it is bending towards the normal, let's say. Then both the rays are meeting here. Wherever refracted rays are meeting, that we call as what? That we call as image. Wherever the reflected rays or refracted rays are meeting, that should be called as image. Okay, now, if you see yourself in the mirror, then all the reflected rays appears to meet behind the mirror. That's why you will see the image of yours. The image negative server. You will see behind the mirror. Okay, this we call as image. This is the object. Okay. Then P2O we call it as object distance. P2I we call it as image distance B, and P2C is radius. All measurements should be done from the P point only. That is the convention we are following. Okay, na? Then what is the U is called as object distance. What is the meaning of object distance? PO is called as object distance. From pole object, the distance of the object from the pole is called as object distance. We represent with the u term. Distance of the image from the pole, we call as what? Image distance. We represent with the v term. This is called as what? Image distance, which we take as what? Pi. Pi we call it as image distance. Okay? PC we call it as radius of curvature. Then what is the relation between the image formation, image distance and object distance? There is a relation. Anybody can tell me? It is there in your textbook. Anyone can tell me what is the relation between object distance and image distance? How many of you know? Raise your hand. How many of you know the relation between the VU? If you want to open your textbook, it's an open textbook question. Open textbook and verify. Anybody found? Dhanush, you know? Okay, we will unmute. Sharon is also know. Very good. Dhanush, tell me.
Dhanush, unmute yourself, ma.
Akhil, no, not that value. Dhanush, unmute yourself.
Yes, sir.
Dhanush, tell me what is the relation?
Sir, to find focal length, we have to separate object distance and image distance, sir.
No, not that, Dhanush. Dhanush, that is not the answer. Sharon, tell me. Sharon, do you know? Dipti, no. You are talking about mirrors. Akhil and Dipti, you are talking about mirrors. In the mirror, 1 by f is equal to 1 by v plus 1 by u. That is for mirrors. I am talking about refraction. Rishita, no, not inversely proportional. There is something different, some relation is there. Usually, I don't know whether that is discussed in the class or that is or that omitted syllabus or what. So I don't know exactly in your 10th standard, but it is there in your 10th standard. What is that relation is I'm writing? You have seen the textbook. Mu2 by v. Mu2 is called as image medium. Image medium by image distance. Minus mu1 by u. Object medium refractive index by object distance is equal to mu2 minus mu1 by r. Where you have to write down the u value, r value. U value, r value with sign. Then you can find out the distance of image. Where the image is found. That we can find out. If you don't know, very good, no problem. Now you learn it. Okay? Mu1, mu2, v and u. R is the radius of curvature. Then when to write down the u value positive, when to write down the r value positive or u value negative, r value negative. That see, inside light direction is towards right. Inside light is going from left to right. So left to right is positive. Left to right direction you have to take positive. Right to left is negative. Dipti, this formula you have to derive. Again, you have to go with this nice law. I1 I2 mu1 I wrote no. mu1 into sin I is equal to mu2 into sin I. So again, we have to take some triangles and we have to derive the formula. Okay. Now you try to learn how to apply the formula. Then derivation automatically you learn later stages. Because that is not relevant now. Okay. Understood? So what is the V stands for? Distance of image from the pole. What is the U stands for? Distance of object from the pole. Then mu1, mu2 are the refractive indices. Remember what is the mu2? mu2 is this image medium. Medium in which image is expecting. We are expecting the image in the what medium? mu2 medium. Where is the object? Object is in mu1 medium. Object on the medium is mu1 and this call. Image of the medium is mu2 and this call. Later and in color we are what is that? Ray travels from mu1 to mu2. Ray mu1 medium to mu2 medium. Ray travels from mu1 medium to mu2 medium. That you can remember. Clear? You are talking about focus, no? Focus is different. Okay, write down. I tell you about focus. Exactly. Sharendra, this is the formula for curved surfaces. This is the formula you have to apply for curved surfaces. Okay, done? All of you wrote down now? Anybody ready? Let me know if you are ready. Completed. Okay, very good. So you people are talking about focus. Let us see what is the focus. Okay. So same diagram I'm taking. This is the principal axis. This is the pole, and this is the center of curvature. Okay. This is the center of curvature, and here medium is mu1. Here medium is mu2. This completely medium is mu2. Left side medium is mu1. Refractive index. Now, what is the meaning of focus? For focus, the ray should be straight. When two parallel lights are incident, light should be parallel to principal axis. Then only you will get the focus. Understood? Focus means what? Parallel lights has to be focused at one place. Exactly. Sun rays are mostly parallel. So that's why if you keep what they say, that magnifying lenses, then entire light will be focused at one point. Okay, I think that you have done. I don't know whether you have done that or not. Huh? Okay. So whenever you want to identify focus, the ray should be parallel. That means where is the object? Object is at infinity. What is the meaning? Object is at infinity. Because we don't know where is the object. We don't know from where these lights are coming. So that's why you can take like object is at infinity. Image will be at focus. Now what will happen? This will refract. Let us say it is bending towards the normal. It is bending towards the normal. So it can be focused at any place. Let us say that it is focused beyond the center. So this will be, okay, these two rays will refract and will meet at one point. That point we call it as focus. Understood? That is the meaning of focus. Getting my point or not? Focus. You focus to the glass. Okay, now what is the meaning? Your entire concentration should be at one point. Like that, these rays will be meet at one point. That point we call it as focus. Now, what is the focal length? P to F, distance we call it as focal length. This entire distance we call it as focal length. Okay, now we can find out. It's not convex lens, it is not concave lens. It is simple medium border. The convex and concave lenses are different, but I discussed it. Okay. What is the somebody typed very lengthy one. But in reflection, we say that that is reflection. Who is asking this? Akhil, that is reflection principle. This is refraction. Both are different. Both are different and you cannot compare. That phenomenon is different. This phenomenon is different. Akhil, in the refraction, there is no Snell's law. No? In the reflection, sorry. In the reflection, there is no Snell's law, but in the refraction, we are having the Snell's law. In the reflection, we will have simply angle of incidence is equal to angle of reflection. But it is not like that. Angle of incidence is different, angle of refraction is different. Actually, okay? So don't compare. Now I want to find out the focal length. We know object is at infinity. And where is the image? What is the image distance? This is the image, no? This is the image. Focus is the image, and this is the pole. Then image distance will be the focal length. Then how to find out the focus? Then you will get mu2 by v formula minus mu1 by u is equal to mu2 minus mu1 by r. Okay? And I told you towards right positive, towards left negative. Okay, now u value is minus infinity because you have to measure in this way. Towards left you have to measure. Then mu2 by v value V value positive towards right measurement. So that's why V value is f minus mu1 by infinity minus infinity obviously. You can keep minus infinity or plus infinity anyway, it will become 0. But P2 object, if you measure, you have to go with the negative. Then mu2 minus mu1 by R value positive because P2C measurement towards right measurement plus R, towards right measurement plus V, towards left measurement minus V. U value is minus. Then this value will become 0 because 1 by infinity will become 0. Then what are the values will get? Mu2 by F is equal to mu2 minus mu1 by R. Then what is the focal length value? Focal length value is equal to mu2 into R by mu2 minus mu1. That is the focal length. Anybody understood? This is the focal length for just medium combination, two medium combination. But whereas lenses, it is different. Lenses is 2-time diffraction will happen in the lens. This is only single time diffraction. Understood? Any doubt? So once you go through it again, if you have any doubt, let me know. I'll explain the next class also. Don't worry. So these are little new things for you. But similar things are there in your textbook. This is something like an understanding the textbook as it is, little deeper. It's not like only formula reading. It's not like only question and answer method. Okay, so it's not like that. It is something different from your regular way of learning. This is called as applicative learning. If you learn in this way, then you will be solving the questions of all competitive examinations. Otherwise, in the competitive examination, you cannot solve the questions. Because in the competitive examination, they don't give the straight questions. They will give always some different questions so that you need to connect with your that concept. Otherwise, what will happen? You cannot answer the question. Yeah, exactly. We call it as logical questions. Okay, na? A little connection from the concept what we learn to the context given. Some context they will give. We have to apply the formula, or we have to apply the concept, or we have to apply the fundamental principles to it. Then you will get the results. Okay, so that way of learning you need to develop. Otherwise, what will happen? You will be your knowledge will be limited to board examination. They will give question. You know the answer. You will write down the answer. If you present your answer in very well, you will get full marks. Okay, na? So, but that methodology won't help you in the future. Okay, so go through all these things again. Write down. I think you people wrote it down. So go through it. We'll discuss it again this time. Okay, na? Hello, student. Okay. So once verified, we will discuss it again. Lens will refract. Lens will allow the light. Sharon, lens will allow the light. Mirror won't allow the light. Mirror will send the light back. You can see through lenses, but you cannot see through mirrors. Okay. Sharon is understood that? Suppose if I keep two mirrors, I can see my eyes back, or else I cannot see anything. Mirror tippet on అది మిర్రర్ మనం ముందు పెట్టుకున్నాం అనుకోండి మన కళ్ళు మనకి కనిపిస్తుంది అంతేగాని మిర్రర్ వెనక ముందు కనిపిస్తుంది అక్కడికి అదే లెన్స్ అనుకోండి స్పెక్టికల్స్ ఇస్ సంథింగ్ లైక్ ఎ లెన్స్ రైట్ అదే లెన్స్ పెట్టుకున్నాం అనుకోండి లెన్స్ లో చూస్తున్నాం అనుకోండి వీ కెన్ సీ అదర్ సైడ్ ఆఫ్ ద లెన్స్ ఆల్సో అందుకే లెన్స్ విల్ రిఫ్రాక్ట్ ద లైట్ మిర్రర్ విల్ రిఫ్లెక్ట్ ద లైట్ అంటే మిర్రర్ మళ్ళీ మనకు వస్తుంది లైట్ అదే లెన్స్ అయితే లైట్ పాస్ చేస్తుంది ఓకేనా సరే. So go through it. If you have any doubt, we'll discuss in the next class. Don't worry. Okay, Dipti, very good. But keep it in your brain. Remember this. Then it will be useful in the future. Okay? Yeah. Okay, so bye everyone. We'll meet in the next class. Okay, bye everyone.